કેમ છો બધા? હોપ બધા જે past lectures છે તૈયાર કરી લીધા હશે. Up to this we have discussed capacitance, capacitor, types of capacitor. Today we will discuss about the dielectric medium. So already we have discussed dielectric medium, dielectric constant, effect of dielectric on capacitance, but now we will discuss in detail. So there are two types of material, conductor and non-conductor, or you can say insulator. Suppose conductor, so when charge is given to the conductor, okay, then it will transfer on the surface. But instead of conductor, if charge is given to the insulator, then charge will remain as it is. It means wherever we give the charge will remain at the same point. Okay, so in conductor, charge will be redistributed and it will be redistributed on the surface. So now dielectric materials are special types of insulating material. So we want to understand if dielectric material is exposed to the electric field, then what will happen? So it will transmit the electric effect or not. So our purpose is we want to understand the effect of dielectric material or effect of dielectric on different parameters. So dielectrics are special types of insulating material which transmit electric effect without conducting. It means it will transmit the electric effect without conducting. So as we have discussed in polarization, so center of positive charge and center of negative charge in normal situation both coincides. So center of positive charge and center of negative charge both coincides. But when this atom exposed to the electric field, then this center of positive charge and center of negative charge will move in opposite direction. So now you can see center of positive charge, center of negative charge. So it will create a dipole moment, or it will create a dipole. So this is the effect of electric field on the atom. So there are two types of dielectric. One is polar dielectric and second one is non-polar dielectric. So first part is polar dielectric. So examples of polar dielectrics are H2O, alcohol, CO2, ammonia, HCl. So all these are the examples of polar. Just for example, consider water. So chemical structure of water. So you can see two hydrogen ion and oxygen ion. So you can see, so center of positive charge and center of negative charge does not coincide. Moreover, there is a dipole moment between positive ion and negative ion in this direction. So you can see the direction along this direction. Similarly, another dipole moment in this direction. So vector A, vector B. So resultant, it should be in downward direction. So you can see this net dipole moment. We can say this is permanent dipole moment. So whether it is exposed to the field or not, there is a permanent dipole moment. So this is for one atom. Now suppose there are number of atoms. Then so in the normal situation, this dipole or these atoms are arranged in such a way that net dipole moment is 0 when electric field is not present. So you can see these atoms or molecules are arranged in such a way that net dipole moment is 0. When this material is exposed to the electrical field, what will happen? So now consider any one atom. Suppose is negative and positive. So when it is exposed to the electrical field, so due to electrical field, okay, a force will act, okay, in the direction of electric field on the positive charge, and in the opposite direction of electric field on the negative charge. So because of this equal and opposite force, okay, so there is a net dipole moment. So it will create a torque on the atom. So this torque will rotate the atom in anticlockwise direction. So because of this torque, now this dipole or atoms will arrange themselves in the direction of electric field. So you can see this. So because of torque, all these atoms will align themselves in the direction of electric field. So now you can see there are negative, positive charge. Here it is negative charge. So it is enlarged view. Actually, this positive cloud will interact with negative charge. So it will nullify the effect. Similarly, here positive and negative, the effect will be nullified. But on the surface, you can see there are negative charges. On the another side, there are positive charges. So as when the field is applied because of polarization, okay, so surface charges will induce. So this negative charge and this positive charge, that is called induced surface charges. So you can see here negative charge, positive charge, and there is a net dipole moment P from negative to positive. So this is the effect of polarization. Now this is for polar dielectric material. Okay, now in case of non-polar dielectric material, so already we have discussed the example of non-polar dielectrics are N2, O2, methane, benzene. All these are the example of non-polar dielectrics. So already we have discussed in detail. In normal situation, positive charge and center of positive charge and center of negative charge both coincides at point. So net dipole moment in normal situation, that is 0. So you can say 0 dipole moment. But when it is exposed to electrical field, okay, so center of positive charge and center of negative charge will move away from each other. So it will create a dipole moment. So you can say this dipole moment is induced electric dipole. So whenever this non-polar electric material is exposed to electrical field, it will induce electric dipole. So now material is whether polar or non-polar. When it is exposed to electrical field, it will create a dipole moment. So now we want to understand the polarization of dielectric slab, or what is the effect of polarization on the electrical field within the material. So now you can see we have inserted a dielectric material between the plates. So on left hand side, charge is positive charge, on right hand side negative charge, and material is inserted. So now due to and direction of electric field is from positive to negative. So due to electrical field, all this atom will align along the direction of electrical field. So now what should be the net electrical field between the plate? So that we want to understand. So now suppose you can consider the electric field line. So electric field line is from positive to negative. So now due to surface charges or due to induced surface charges, some of the field line will terminate and some of the field line will pass through the material. So naturally, the net electrical field within the material or between the plate should be less than original field. Moreover, again there is a, so here there is a positive charge, here it is negative charge. So there is a net electrical field. So you can see within the material also there is a electrical field. So that is called induced electrical field. So induced electrical field, that is called EI. And direction of this field is in opposite direction of E. So now because of this EI, now what should be the net electric field between the plate? So net electrical field between the plate, it should be E minus EI. So this E dash is equal to E minus EI. So this is called net electrical field between the plates. So E dash is always less than E. So E dash is equal to E minus EI. So if we want to consider the dielectric effect, then we have to do lots of calculation. So that is not the scope of this book. So we can consider the effect of decrease in the electrical field by considering a constant, and that is called dielectric constant. So this constant we are using to consider the decrease in electrical field, and this constant is the ratio of original electrical field to the reduced electrical field. So E upon E dash is equal to K. So K is called dielectric constant. Sometimes it is called relative permittivity of material. So ER. So E0, that is relative permittivity of the space, and ER, that is called relative permittivity of material. So normal case, value of E is always greater than E dash. It means value of K is always greater than 1. But in free space, in the free space, E is equal to E dash. So that is K is equal to 1. So dielectric constant for the vacuum, that is equal to 1. Already we have used this dielectric constant in the previous chapter. So dielectric breakdown, so already we have discussed when we discuss capacitance, when charge on the capacitance, so when charge on the capacitance, sorry, conducting material increases, okay, so polarization of material also increases. Because of polarization, so there are two equal and opposite force. So with increase in charge, electric strength of the electrical field increases, and with increasing strength of electrical field, force also increases. So if this force, value of this force is more than strength of the bond, then bond will break, and this material will move. Okay, so it will be divided into two parts. One is negatively charged, second one is positively charged. It means this insulating material now behaves like a conductor. So now it will lose its insulating property and it will behave like a conductor. So whenever if electrical strength of electrical field is higher, then bond will break, and this phenomena is known as dielectric breakdown. So we cannot increase the capacitance beyond certain limit, and this capacitance depends on the material. So if dielectric strength is higher, so we can use it for higher capacitance. And next is dielectric strength. So that is the maximum capacity of dielectric material which can withstand without breaking. So this is called dielectric material can tolerate without its electrical breakdown. It is called dielectric strength. So both these phenomena already we have discussed when we have discussed capacitance. So now we want to understand the effect of dielectric. So already we have discussed on capacitance. So with presence of dielectric material, capacitance increases. But what is the effect of dielectric material on other parameters like charge, capacitance, potential E, potential energy U? So now when we fill the dielectric material between the plates, now there are two options. One is dielectric material is completely filled up, or it may be partially filled up. So first we will consider the dielectric metal is completely filled between the plates. So now we want to understand the effect of this dielectric material on various parameters. So now you can see various parameters: capacity, charge, potential, intensity, energy. So already we have derived all these relations, so we know all these relations also. So now we want to understand the effect of dielectric on the parameters. Now again there are two options: capacitor, it may be connected to the battery or it may not be connected to the battery. So now consider the first case, the capacitor is not connected to the battery, it means battery is removed. So now in first case, capacitance C. So when we fill the dielectric material, so already we have discussed, capacitance increases by K times. So C dash is equal to Kc. So now what is the effect of dielectric on the charge? So now this capacitor is not connected with the battery. It means we are not adding or we are not removing additional charge. It means charge should constant. So Q dash is equal to Q. So charge remains constant. Next is potential. So potential V. So potential V is equal to Q by C. So Q is constant and C dash is equal to Kc. It means potential decreases by K times. So V dash is equal to V by K. Now intensity. Intensity E is equal to Q by A epsilon 0. So instead of epsilon 0, you can consider epsilon R or you can say K. It means intensity of field decreases by K times. Now energy. Energy is 1/2 CV square or you can use Q square by 2C. So which one is advisable? So here Q is constant. It means second equation. It means potential energy decreases by K times. So U dash is equal to U by K. So you can see generally we find example based on this. Now we can consider the another case when capacitor is connected to the battery. So battery remains connected. Now first part, capacity of the capacitance increases because of dielectric material. So C dash is equal to Kc. Now charge. So if capacitor is connected to the battery and if capacitance of capacitor increases, naturally the charge on the battery will change. So if capacitance increases, then charge also increases. So it means now Q dash is equal to K. Now what should be the potential? So as we have discussed, when capacitor is connected to the battery, so in steady state condition, the charge on the capacitor and charge on the battery should be same. It means V dash is equal to V. So now you can say potential is constant. So now intensity E is equal to Q A upon epsilon 0. So Q is equal to, you can say K, Q dash is equal to KQ, and here again it is K. So finally intensity remains constant. So E dash is equal to E. Now what about the potential energy? So U is equal to 1/2 CV square or Q square by 2C. So use first one, potential is constant. So C dash is equal to Kc. It means potential energy increases by K times. So U dash is equal to U K. So now no need to remember this, but you can understand it or you can derive it whenever it is required. So generally you will find question based on it. Now suppose in the example it is not mentioned whether battery is connected or not. In that case we have to assume that battery is disconnected. Otherwise in the example it is mentioned capacitor is connected to the battery. So now second case, when dielectric is partially filled between the plate. So now you can see the plate and suppose thickness of this plate, assume thickness is T. So now suppose space or distance between the plate is D and thickness of the plate is T. So now we want to understand the effect of this dielectric on the capacitance. Suppose it is fully filled up, then capacitance increases by k times. But here, whether it is k times more than that or less than that. So now to derive the relation, again consider the first case. Suppose we want to derive the relation for C dash. So C is equal to Q by V. So first we have to calculate potential. So now calculate the potential difference between the plate. So now potential V is equal to E into D. It means potential depends on distance, or you can say in general case E into R. So depends on distance R, and E means electrical field. So whenever we consider electrical field, so electrical field is different in the airspace and electrical field is different in the material. It means we have to divide the region into number of parts. So you can see free space, material and free space. So we can combine this free space and material part, because in the free space electrical strength is E, in the material electrical strength is E dash. So now potential, you can say suppose V dash is equal to electrical field strength E and thickness. So thickness is the total thickness D, but thickness of the material T. So you can write D minus T. So that is for free space. Now for material, so you can write plus. So in the free space, that is electrical field strength is E dash and thickness is E. So now you can see this is potential. So now replace E dash. E dash is equal to E by K. So now you can see the relation. So V dash is equal to E D minus T plus E dash into T. So now replace E dash by E by K. So E D minus T plus E by K into T. Now take it E common. So E, so into the bracket D minus T plus T by K. So you can see E D minus T plus T by K. So now replace E. E is equal to sigma upon epsilon 0. Now again sigma, instead of sigma in terms of charge Q by A. So Q by A epsilon 0 T minus T plus T by K. So this is potential after inserting dielectric material between the plates. So now we want to calculate capacitance C dash. So new capacitance C dash is equal to Q by V. So now V dash, so here if we write Q, then Q cancel. So A epsilon 0 upon D minus T plus T by K. So now you can see this new capacitance. So this value of capacitance, if we consider thickness, so T by K, value of K is always greater than 1. It means this value is always negative. It means overall C dash is always greater than C. It means with insertion of dielectric material, capacitance increases, but not K times, but it is different than K times, and this value is T minus T plus T by K. So this parameter is called effective distance. This parameter is called effective distance. So in normal equation, you can replace D by D minus T plus T by K. So this is called effective distance. Now in examples, you will find instead of one plate, there may be number of plates. So now you can consider number of plate with different dielectric material. So you can say K1, K2, K3, all are the different dielectric material which are placed between the plate. So now one option is you can derive the relation. You can consider all these capacitors are connected in series or maybe in the parallel. So by using this law of capacitance, so our next topic is capacitance are in series and capacitors are in parallel. But now, without considering the theory, directly we can use the relation by using the technique. So now suppose already we have derived the relation C dash is equal to epsilon 0 a d minus t plus t by k. Now in this equation E0 and a both are same. Okay, so these terms related with effective distance. So now you can see d minus t and second one is t by k. So d minus t that is related with free space and t by k that is related with dielectric material. So similarly we can use the same logic for this multi dielectric material also. So now first part, calculate free space. So now for free space, so d, and suppose thickness of first T1, T2, T3. So now free space thickness is d minus T1 plus T2 plus T3. So that is for free space. And for T by K, you can use T1 by K1, T2 by K2, T3 by K3. So final equation will be epsilon 0 a d minus T1 plus T2 plus T3 plus T1 by K1, T2 by K2. So this is for dielectric material and this is for free space. So easily now you can remember it. Even from the basic fundamentals we can remember it. Now suppose instead of free space, this space is completely filled up with different types of material. So you will find such type of examples also. So in the exam, no need to remember or no need to derive the relation. Directly you can use our equations. So now there is no free space. So now modify this equation. So K1, K2, K3, T1, T2, T3, T4. So consider all these parameters. Now free space. So free space is 0 because d minus t that is 0. It means no need to consider this term. So now consider only this term. So this term is T1 by K1, T2 by K2, T3 by K3. So now C dash is equal to E0A T1 by K1 plus T2 by K2, T3 by K3. So now you can use this relation. So based on the requirement, by using this concept, you can modify the equation. Now instead of dielectric, sometimes in the example you will find the metal is inserted between the plate. So now in this situation, suppose metal plate is inserted between the plate. So now in this situation, what should be the value of capacitance? So now as per our equation, C dash is equal to epsilon 0 a upon d minus t plus t by k. So now for metal, k is infinite. It means t by k value is 0. It means we have to consider only d minus t. So epsilon 0 a upon d minus t. Now if thickness of this material is same as d, it means fully filled up. So now in this situation, you can see capacitance C dash is 1 upon 0. It means infinite. So it means instead of this material, you can see you can connect both the plate or both the terminal by the wire. So that is, you can see simple, you can connect with the wire. So in this case, capacitance is infinite. So this is phenomena. This phenomena is known as short circuited of capacitor. So this phenomena is known as short circuited of capacitor. So next, in the next lecture, now we will discuss the separation. What is the effect of separation between the plate? I hope all of you enjoyed this video. So we have improved our quality a lot. So we are expecting your feedback. Okay. So thank you very much.